Dear students, I am Dhananjay from ddphysics YouTube channel. In this video, I am going to explain 5 important points in chemical bond about hybridization. The first point is what is hybridization, and second point SP3 hybridization, third point SP3D Square hybridization, fourth point SP2 and SP hybridization, and fifth point SP3 hybridization. Now first one, what is hybridization? The process of the intermixing of atomic orbitals of almost same energy and their redistribution into an equal number of identical orbitals is known as hybridization. In this definition, intermixing of atomic orbitals is very important. Hybridization is occurred in one atom. Next, SP3D hybridization. In phosphorus pentachloride PCl5, SP3D hybridization is occurred. Let me explain. In phosphorus pentachloride, the central atom is phosphorus. Phosphorus atomic number is 15. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Generally we write electronic configuration up to 3p3, but here we need empty d orbitals also, so we write 3d0. Valence electronic configuration in first excited state. What is meant by first excited state? If you give some energy to the phosphorus atom, the electrons will get the energy and jumps into empty orbitals. Now one electron from 3s orbital moves into 3d orbital. So the valence electronic configuration in first excited state is, it will become 3s1, 3p3 and 3d1. Now in first excited state, phosphorus intermixing of 1 s orbital and 3 p orbitals and 1 d orbital to form 5 sp3d hybrid orbitals. These 5 orbitals overlap with 3pz orbitals of chlorine atoms and form 5 sigma bonds. Shape of molecule is trigonal bipyramidal and bond angles are 90 degrees and 120 degrees. Here you can observe the diagram of phosphorus pentachloride. The shape of phosphorus pentachloride is trigonal bipyramidal. Here 3 chlorine atoms in the plane and remaining 2 chlorine atoms are out of the plane. That means it is perpendicular to the plane. Here 2 chlorine atoms in the plane, the angle between 2 chlorine atoms is 90 degrees and the remaining 2 chlorine atoms which are perpendicular to the plane is 120 degrees. So the bond angles are 190 degrees and 120 degrees. Here the 2 covalent bonds are denoted, one is in dotted line and one is thick line. These 2 bonds are also covalent bonds, but these 2 chlorine atoms are not in the plane, so it is covalent bonds are denoted like this. Next, SP3D Square hybridization. So SP3D Square hybridization example is sulfur hexafluoride SF6. The central atom in sulfur hexafluoride is sulfur. Sulfur atomic number is 16. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4, 3d0. In first excited state, valence electronic configuration is 3s2, 3p3 and 3d1. That means one electron from 3p orbital moves into 3d orbitals. So 3s2, 3p3, 3d1 is the valence electronic configuration in first excited state. In second excited state, valence electronic configuration of sulfur is 3s1, 3p3, 3d1. Here also, one electron from 3s orbital moves into 3d subcell. So therefore, the electronic configuration becomes 3s1, 3p3 and 3d2. So sulfur has 6 unpaired electrons in valence cell. So with these 6 unpaired orbitals, in second excited state, sulfur intermixing 1 s orbital, 3 p orbitals and 2 d orbitals to form 6 SP3D Square hybrid orbitals. These 6 orbitals overlap with pz orbitals of fluorine atom to form sulfur hexafluoride. Shape of sulfur hexafluoride is octahedral and bond angle is 90 degrees. It is a sulfur hexafluoride structure, octahedral structure. You can observe 4 fluorine atoms in the plane and 2 fluorine atoms are out of the plane. So one is above the plane and other one is below the plane. Next, we are going to understand formation of beryllium chloride. In beryllium chloride, central atom is beryllium. So beryllium atomic number is 4. Electronic configuration is 1s2, 2s2, 2p0. In first excited state, valence electronic configuration is 1 electron from 2s orbital moves into empty 2p orbital. So the valence electronic configuration in first excited state is 2s1, 2p1. With these 2 unpaired electrons, in the first excited state, intermixing of 1 s orbital and 1 p orbital form 2 sp hybrid orbitals. These 2 orbitals overlap with p orbitals of chlorine atoms and form 2 sigma bonds. Shape of molecule is linear and bond angle is 180 degrees for beryllium chloride. If you observe the structure, you can understand this. So beryllium chloride have this type of structure. At central atom is beryllium. In beryllium, there is 2 sp hybrid orbitals are formed. With the use of these 2 sp hybrid orbitals, beryllium overlap with p orbitals of chlorine atom and also 2 chlorine atoms. So therefore, beryllium chloride has linear shape and bond angle is 180 degrees. Next one, SP2 hybridization, formation of boron trifluoride. In boron trifluoride, the central atom is boron. Boron atomic number is 5. Electronic configuration is 1s2, 2s2, 2p1. In first excited state, valence electronic configuration is 2s1, 2px1, 2py1. So in first excited state, so if you give some energy to the boron, one electron from 2s orbital moves into 2p orbital. So the valence electron, I am writing only valence electronic configuration. Here 1s2 is not taken here because in first excited state, valence EC means electronic configuration. 2s1, 2px1, 2py1. In the first excited state, intermixing of 1 s orbital and 2 p orbitals to form 3 sp3 hybrid orbitals. sp2 hybrid orbitals, These 3 sp2 hybrid orbitals overlap with p orbitals of fluorine and give 3 sigma bonds, not 5 sigma bonds. There is a mistake here. So here 2. Next, the shape of molecule. The shape of molecule is a trigonal planar and bond angle is 120 degrees. So here you can observe that the diagram of boron trichloride. So in boron, 3 sp2 hybrid orbitals is here. So with the use of these 3 sp2 hybrid orbitals, boron overlap with p orbitals of 3 chlorine atoms to form boron trichloride. This is the. Here you can observe on the right side bond structure of boron trichloride. Boron trichloride, boron combines with 3 chlorine atoms with single covalent bonds. Then the bond angle is 120 degrees. So the next one, SP3 hybridization, formation of methane. In methane, carbon is the central atom. In carbon, ground state valence electronic configuration is 2s2 2p2. This is valence electronic configuration. In first excited state, valence electronic configuration becomes 2s1, 2px1, 2py1 and 2pz1 because one electron from 2s orbital jumps into 2p orbital. In first excited state, intermixing of 1s orbital and 3p orbitals of carbon atom forms 4 sp3 hybrid orbitals. These 4 orbitals overlap with 1s orbitals of 4 hydrogen atoms and form 4 sigma bonds. Shape of molecule is tetrahedral and bond angle is 109 degrees 28 minutes. Here you can observe on the left side screen orbital structure of methane, on the right side bond structure of methane. In the orbital structure, the central atom is carbon. At carbon, SP3 hybridization is happened, so 4 SP3 hybrid orbitals are formed. With the use of 4 SP3 hybrid orbitals, carbon combines with 4 hydrogens, s orbitals of 4 hydrogens to form methane. So in methane, adjacent bonds angle is equal to 109 degrees 28 minutes and structure is tetrahedral. Thank you for watching.